Good morning and welcome to the third and last event in our series of 3 hours online seminars, which are organized by the ELMA project and which will give you insights to the state of the art of electric water mobility, today under the heading Norway Revisited Next Generation Electric Ferries and Pack Ship. We are very glad that this event found such a great interest with a lot of registrations and also with a lot of countries today represented here. We have representatives from Germany, Poland, Lithuania, Latvia, Sweden, Finland, Denmark, Norway, the UK, and the Netherlands that registered today for the event. And I see that still participants are coming in. And it's also a wide range of different institutions here and profiles covered. So we have public authorities among us, academia, ferry operators, shipyards, naval design companies, and also other suppliers from the shipbuilding sector. So I hope that we will not only have interesting presentations today, but also interesting discussions in this group. So my name is Jens Masoch, and from Gamma Consulting, we are assisting the lead partner, the Economic Development Cooperation Vorpommern from Germany, in the implementation of the ELMA project. And today it will be my task to guide you through this ELMA seminars. And before we go into content matters, and I will introduce the agenda and what you can expect today a bit more in detail, I would like to give the floor to Mr. Mario Heinrich from the lead partner, the Economic Development Cooperation Vorpommern, for some welcome words and also for some words about the ELMA project. So please, Mario, the floor is yours.
So, hi all together. First of all, can you hear me? Okay. So, point set. I hope I can add a little bit. Hello all together, also from my side. Thank you for being here and welcome to our third online seminar this June, Revisiting Norway. It called Why is it Revisiting? In 2018, the ELMA project had a very fruitful study trip to Norway. In this time for years. It was a face-to-face event, and it was a really great and, as I said, fruitful trip. My name.
Mario, you keep disappearing.
Yes, Mario, we have some problems with your connection, I would say. Yep. Okay. Yeah. So I think there is Mario is from Germany. We are not the world champions in broadband connections, as everybody knows. So I guess there are some connection problems on his side. So I hope he can reconnect again and say later a few words. So then maybe from my side, a few words about the ELMA project. ELMA is an international cooperation project that is financed from the South Baltic Interreg program. It was running or is running for 4 years. We are in the very final phase now, and the aim of the project is to promote electric mobility on the water. On the one hand, we want to equate public authorities with the opportunities, and on the other hand, we also try to assist companies to get to know more about electric water mobility in order to enter also the international supply chains in these sectors. And Mario has mentioned it. One of our strands of activities are also information events. Mario managed that. We have been to Norway in 2018 for a face-to-face study trip. At that time it was still possible, and I think it was very, very fruitful. And this is also why we called the event today Norway Revisited. So we will have another look to Norway today, to the world's leading country in introducing electric car ferries and passenger ships, where more than 80 of such vessels are today already in operation. Like we said, this event is thereby of course, also for new participants, but at the same time, a follow-up and update of the first event, this study trip. When we visited Norway, it was in September 2018. There, the main attraction in Norway was the world's first all-battery electric car ferry, the Ampere, which we visited and which we also had a test run then. A lot of happened since then, and Norway has moved on from this first pilot vessel to a really impressive and wide rollout of electric water mobility based on the one hand on a very strong political will and support to make waterborne transportation emission free, and resulting also in a very wide range of different electric vessels in operation or in the concept and construction phase. So you have here a little bit visualization of, I would say, the electric water mobility scenery, how it is nowadays in Norway. You find here the big picture. This is the Ampere that we visited in 2014. So the first all-electric car ferry, a short distance domestic car ferry. And here you can see also the other vessels that you will learn more about during today's events. So some words about the agenda in the beginning. So here you see it. So our first block will be, we have called it Norway Revisited. So we will start with an overview and an update on governmental actions to promote the wider rollout of battery electric and also hydrogen ferries in Norway. And we are very happy that Anders Sæternes from the Norwegian Public Road Administration joined us again and will give a presentation on this subject. Then we will have a look into different vessel types. And the first one will be the next generation battery electric car ferries that were introduced by the ferry operator Fjord 1. And here we have Stein Ruben Larsen from Norwegian Electrical Systems, which is the system integrator for this ferry, who will acquaint us with these types of vessels. Next, we will then have a look at a little bit of different use case, larger type of vessels, which also get more and more into focus. So it's about large RoPax vessels, and Robin Tomrin from Color Line will present us the design, but also first operating experience with the world's largest plug-in hybrid cruise ferry, the Color Hybrid, which is operating the international line from Sandefjord to Strömstad. And then last but not least, we have another type of vessel, and here we will be acquainted with the latest project of one of the pioneers of electric water mobility, the Fjellstrand shipyard, which had also built the Ampere, and this time Edmund Tollo will tell us more about the world's first all-battery driven fast ferry that is designed in accordance with the HySeas regulation, the Medstraum, which the key laying of which just took place last week, and I think we will also get some pictures from this. So this is our part Norway Revisited, and then we are a little bit inconsistent to the name of the seminar, and we will have a glimpse to Scotland. Why? Because also there is an innovative and very interesting project going on, and I can tell you in which also Norwegian expertise is of course involved. And there it is about the world's first seagoing car and pax ferry with hydrogen electric propulsion, which is currently being projected. And we are glad that John Selton from Caledonian Maritime Assets and Christina Mikkelsen from Ballard Power Systems, which is responsible for the fuel cells, will give us insight into the status and the progress of the HySeas III project. So this is our plan for today, and after each presentation we will of course also have time for your questions. So you can either use the chat function to post your question. We will then take them up and forward them to the speakers, or you can also just raise your hand or raise your voice and just just pose your question directly into your microphones. I would really like to encourage you to use this opportunity and to make this seminar really an arena to pick up specific knowledge and information that you would like to have. So that's the overview. And now let's start with the first presentation. I would like to give the floor to Anders Sæthernes, the special advisor and head of the ferry group in Western Norway at the Norwegian Public Road Administration. Statens Vegvesen, this is the Norwegian name, is responsible for, among other things, the tender processes for domestic ferry services. When we visited Norway in September 2018, Anders told us about the ambitious goal of the government to have 50 electric ferries in operations by 2021, and I'm very curious to hear how far Norway has come in the meantime with regard to battery electric ferries and hydrogen ferries, and also what will be the future and the next steps into zero emission waterborne transportation. So, Anders, please, the floor is yours.
Hello, my name is Anders Sæthernes, and I'm the acting department director in the Norwegian Public Road Administration Ferry Department. The last time I spoke to you was in 2018, and then we were at the beginning of the green shift. And today I will tell you a little about how things have gone since then. The Norwegian ferry market is more or less the same as last time I spoke to you. We have about 130 ferry routes and about 200 car ferries. We have about 22 million vehicles and 44 million passengers every year. The routes are operated by private ferry companies throughout competitive tendering. The annual turnover is about 6 billion Norwegian kroners. That's about 600 million euros, I think. About half of this is state subsidies. The other half is ticket incomes. The Norwegian Public Road Administration are the largest demander in the Norwegian ferry markets. We have 16 routes and about 10 million vehicles and a turnover of about 3 billion Norwegian kroners, which is roughly the 50% of the Norwegian ferry market in value. I said something last time about the political and governmental requirements. We got early, already in 2014, for the budget for the year of 2015. The government is requested the parliament to ensure that the requirements for zero emission technology are included in the future tenders for public ferries. And we have also a white paper in a year later that said that all ferries should, where possible, be electrified within 2030. We have some new governmental requirements since then. All tenders should be zero emissions by 2026. And for the national routes that the NPRA are responsible for, we have we have only used the requirements for zero or low emissions since 2017. So we do not have any tender with diesel anymore. We had set up some success criteria or prerequisites in order to achieve our goals. It's important to have involvement and commitment from the Norwegian authorities and NPRA management regarding the ambitious and direction of the development. Funding is obviously important, and the funding should reflect the level of ambition. We need a competent and professional procurement organization that secures cost-efficient procurement of ferry services. We need close dialogue with the market. It's a joint effort from the public procurers in the ferry market. That's important to reach a critical mass in the market. So it's very important that the national routes is not alone in setting requirements for zero emission. We also need the various county routes to set similar requirements. We need consistent and predictable requirements, and it's important that they are predictable over several years and also over several contracts. So we need predictable requirements for a period of more than 10 years. We need market development and measures to secure the long-term development of the ferry market. And in individual tenders, assessment of economic risk and on the ferry companies and predictable conditions. There is a need for a first mover who is able to bear the cost and risk related to the pilot. The pilot you visited the last time you were in Norway, MF Ampere, was required through a competitive dialogue in the market. After that, it got more regular minimum requirements in the contract. Based on our experience, we believe that the public procurement is a good tool to develop and implement new technology. However, other forms of public-private partnership or private initiatives could also work often in conjunction with the public funding schemes and so on. We have to bear in mind that the way we act as a procurer and public agency has a great impact on the market that we do the procurement in. Secondly, it's important with the strategics and funding schemes to take the technology from pilot to market. A critical mass of procurers, public agency, and private actors that apply constant and predictable requirements over time can contribute to incremental innovation, gradual improvements of the new technology, and such range of electrically operated ferries and charging. Development of the value chain related to new technologies from ferry to electric grid products and distribution of hydrogen demands higher volumes, contributes to lower to cost, and makes the new technology more available. Especially on the electric ferries, there are some things I like to point out. It's urgent need to get the ferry charged every time it's on the pier. In the Norwegian ferry markets, we need newly charged batteries about 2 million times a year. The Norwegian ferry market need batteries to be charged or changed on 300 quays. And it has to work every time. If it does not work, the public service would be lower than with the diesel ferries, and that's not an acceptable development. And so far, we mean that there is still a need for technology development across the chain from grid to ferry. The ferry itself, we are very pleased with, but we have some difficulties in the chain from the national grid and out to the pier that need to be addressed in the coming years. Oh, how has it been since last time? At present, there has been signed contract that will result in close to 80 ferries with battery on board in operation in 2022. Our initial goal was 50 ferries by 21. Due to COVID-19, we have some delays, but we have more or less overachieved the initial goals. So when we get all the ferries that are delayed due to COVID-19 in the autumn of this year, we will have around 80 ferries next New Year with battery on board. And there are more on the way. Both the national and the county road network has get many new battery ferries, and this number of 80 also includes some initiatives from the shipping companies themselves to install batteries in older ferries. This shows that we do not stop with the pilot. We have continued to make requirements over time in order to take the technology through the early technological phase from pilot to market. We believe that we, for a large number of contracts, will save money in the subsequent contract period, due to the fact that in Norway electricity is cheaper than the alternative fuel, and electric ferry has so far a lower maintenance cost than diesel operated ferries. Last time I showed you this. In relation to this plan, we are now a little late due to COVID-19. The ferry is finished produced, with the exception of the hydrogen system. Currently, plan is start up with the hydrogen in April 22. Here is a picture of the ferry MF Hydra in tow from Turkey to Norway in December last year, and currently it's placed on a shipyard in Ølen to finish the hydrogen system. Despite that we do not have this ship sailing with hydrogen yet, we have moved to the market with the next contract with the hydrogen. It's a connection called Bodø Røst Værøy Moskenes. It's in the northern part of Norway. It's a ferry from the mainland to two remote islands way out in the Norwegian Sea or the Barents Sea. It is a 15 years contract with startup from 1st of January in 2024, and hydrogen requirements from 1st of January 25. It's two main vessels in year-round operation, who can take 120 cars and 12 lorries, with a requirements to 85% hydrogen and 15% biofuel or electricity, and redundant fuel systems. This also show, and when it comes to hydrogen, we are now moving forward from pilot and facilitating commercialization of the technology. We have to bear in mind that the way we act as a procurer and public agency has a great impact on the market that we do the procurements in. Thank you for the attention.
Thank you very much, Anders, for your presentation and for the overview once again, and also the update on the governmental actions. Are there any questions from the audience about this part? Okay, so maybe a question from my side. The first pilot was Ampere. Ampere, as I remember, was an all-electric ferry which kind of operated 100% in full electric, battery electric mode. So is this still what you require now in your tenders, or were there changes, and maybe also with this regard or with other regard, lessons learned from the pilot phase to the, I would say, the distribution phase now?
There have been some changes. Most of the tenders now allows up to 5 or 10% use of some other zero emission fuels, such as hydrogen or liquid biogas or other biofuels. That's in order to have a secure operation also when there is power failure in the national grid. It's rarely a big problem in Norway. We have a fairly stable national grid, but it sometimes happens. And when you have several ferries in one connection, it's not with them, such as Ampere, it's not so critical if Ampere doesn't go because of there are 2 more diesel vessels in that connection. But when we wish to move all the ferries to electric, we have to have some kind of secure transport when a rare occasion of power failure in the national grid will occur.
Okay, so you allow, I think, depending on the route, 5% to 15% of biofuel, you say, operation of the ferries. So how is it in reality? If you look at the performance of the rules, do the operators use this option, and to which extent?
I looked into one of our connection this morning that has 2 electric ferries in operation. They can use up to 15% biofuel. The total consumption last year of biofuel was 2.8%. So they use electric whenever they can.
Okay, because it's cheaper for them, I understood, because of the energy prices in Norway, or?
Yes, we have a fairly nice energy price on renewable electric energy in Norway. And the cost of biofuel is more or less the same as there is in rest of Europe. So it's a good difference in price. Electric is way cheaper, and the total energy consumption is way less when you are going on electric contra combustion engine.
Okay, we have a first question from the audience, and the question is about the market also in Norway. How do you estimate the demand for electric ships in Norway? So how many more ferries will be needed, and also in what period this transition should go on?
I think I would say that in course of the next 10 years, we will need roughly 100 more electric ferries in Norway.
There is another question, and this comes back to this question of going with biofuel and also electric. So what is the price relation between electric kilowatt hour and diesel kilowatt hour? So what is the price relation in Norway, and maybe also connected to this, biofuel? So what kind of fuels do you allow the operators to use as alternative to electric and hydrogen?
We are allowed to use biogas, hydrogen, or second generation biodiesel. The cost difference, it varies because the electric cost is not the same all over the country. It depends on where you are and how strong the grid are. But per kilowatt on board the vessel, the price is I think 3-4 times cheaper with electric than with biofuel. But you have to bear in mind that the biofuel, also the electric drive system has efficiency for around 90% from batteries to propel, but the efficiency through internal combustion engine is like 40%. So relatively set, you have to have much more diesel than electric power. So I think if you look at the power on the propel, the cost is 10 times higher with biofuel than it with the electric.
Okay. So now a lot of questions coming in. One question I take before I screen the other ones was related also a little bit looking the step further. So electric vessels also needs less staff on board and less maintenance on board. So are there also plans, to go with into the direction of autonomous ferries in Norway from your side?
Yes, but I think that is some years ahead of us. But there are small test programs around Norway with various degrees of autonomous work. I think the first generation now will be auto docking systems and auto crossing system to get the best fuel efficiency, not auto crossing system to get rid of the captain. Auto crossing system to help the captain with an economic and safe voyage, I think.
Okay, there are questions related to hydrogen. I will get back to them a little bit later. So first, one last question here to the battery. So there is the question, what kind of cell chemistry do you prefer on the vessels, and what are your criteria from the specification at the moment?
We have a set of function requirements, so we do not set specific requirements for battery chemics or battery systems. The function requirements is based on time in operation and minimum time in operation, and the companies themselves has to choose the battery chemistry.
Related to that, also one more question. There has been in the media, you have seen that there has been some incidents in the last years, some battery fires on ferries. I think one was in March this year. this Brim, I think, and then the Uteröingen, if I pronounce it right, it was in 2019. So when it comes to the requirements that you set in the tenders, does this have any influence on the development here on your side?
So far, it hasn't had any influence on the requirements in the competition. The fire on Uteröingen shows there are some challenges that we have to meet with battery technology and fires, but it also shows that the fire brigades needed a different set of skills and a different set of equipment to cope with such battery fires. We need to study this a bit more to conclude, I think.
Okay, so now there are also some questions regarding the hydrogen ferries that you mentioned. Maybe let's go for the final part a little bit into that direction. So you mentioned that you have on the one hand tenders for battery electric ferries, which are now hybrid ferries because they always have this redundant fuel systems. And then on the other hand, you also go into a first pilot with a Hydra for hydrogen ferry, and then the second one that you just announced that will start in 2024. So here the question is, so what is how do you see what kind of routes are more appropriate for hydrogen ferries and will be oriented into that way? What are your plans with this regard? Which ones for battery electric ferry? And related to this, there is also a question from Robin Tomrin from Color Line. If you think also of an option not to define the propulsion specifics and requirements, but instead to set limitations as for CO2 or greenhouse gas emissions, and then to leave it totally up to the ship operator to select the best technology.
The route to Bodø, Værøy, Røst, Moskenes, it's one of the longest ferry routes in Norway. The longest crossing from the mainland to the island far out in the sea. The voyage is about 3 hours. So with electric ferries, we will always prefer electric ferries if there is enough power in the national grid available. And we will always prefer electric ferries as long as the voyage is so far in a such way that it is technological possible with electricity. We will prefer that. But on the longest route and or route where there is no main grid available, we prefer hydrogen. To the question if we would consider a cap of CO2 emission and leave it to the market, our strategy so far has been and will be for some time more to through public requirements set demands that creates a strong technology base for battery ferries, and we believe that the battery and electricity is the future. So we do not wish to go via some carbon capture technology or other things. So that's our strategy.
Okay, so we are almost over the time. One last question I see here in the chat, also related to environmental requirements in the tenders. So, what happens with the used batteries? You have also requirements with this regards defined to your ferry company.
For the first contracts, we do not have any requirements on specific requirements from our side how to get rid of used batteries, but there will be a national set of rules of how to discard batteries, and it's possible that we in the next contract will set requirements on more specific requirements on the battery technology and also discarding of used batteries.
Okay. Yeah, I do not see any further questions on this part. Then I would like to thank you, Anders, for joining us again and giving us an update on the from the governmental side on this topic, on the green shift of the Norwegian ferry market. Thank you very much, Anders. And I hope we will one day be able to visit you again and have a look how things are proceeding in the next years.
Yes, thank you very much, and I hope when COVID-19 is over that you all will take a new trip to Norway, and we will show you around on the newest battery ferries, and by then I think we also will have a hydrogen ferry to show you.
Yeah, sounds very promising. Thank you very much, Anders.
Bye-bye.
Bye-bye. Yeah, so this was the government perspective, the policy perspective on the rollout of electric ferries and pax ships, passenger ships in Norway. We will now move on and to the first kind of focus more on specific vessels, and this is about the next generation battery electric car ferries, which were introduced by Fjord1. So it was in 2020 when Fjord1, so one of the largest domestic car ferry operators in Norway, brought into operation not only one or two vessels, but really ordered a series of 5 ferries. And this was also looked at by many people as a sign that now battery electric ferries really leave the pilot stage and on the way to become the mainstream, you can say. So the propulsion systems of these ferries, they were delivered by Norwegian electrical systems, which acted as a system integrator, and Norwegian electrical systems was not only responsible there for the onboard package, but also for the onshore charging infrastructure. And this was also something that Anders already addressed in his presentation, that in the event that more and more electric ferries go into operation and you have this huge number of charging events that you have to cover, so 2 million times a year, Anders said that this is also of course a challenge for the grid, and that this needs also specific solutions for that. And I would like to give the floor now to Stein Ruben Larsen, Senior Vice President Sales of Norwegian Electrical Systems, which will go a little bit into these topics in the following presentation. So, Sten Ruben, the floor is yours.
Thank you, Jens. I guess you can hear me and also see the presentation.
Yes.
Very good. So yes, my name is Stein Ruben Larsen, responsible for sales in Norwegian Electric Systems. We are what we call a system integrator. I will, during my presentation, try to explain what that actually is, and also, of course, go into some details about this specific ferry route for Fjord 1, where we had a challenge on a very weak grid on an island on the western part of Norway. In the beginning, of course, Norwegian Electric Systems, we have maritime routes all the way back to the 1980s, where we specialized on converter technology. So basically, we are divided into two different ways of working. We have what we call an energy design department, where we do study the propulsion line in a vessel. And we also have a smart control department, where we do all the automation, navigation, and other digital platforms. When we start a project, we, as Anders said, there is requirements from the public authorities that we need to take into consideration. We also need, of course, to take into consideration the requirements from class rules and the ship owners' requirements for the operation of the vessel, and also from the designer's point of view, how to implement our systems into the vessel. So we have a three-level way of thinking, where at the top side here you can see everything related to safety, efficiency, and environment. And this is very important for system integrators to have a deep knowledge on this, because that's the only way that we can fulfill all the requirements and also optimize the system. So just for an example, for this ferry project here, we knew that it was going to be a zero emission vessel. We had to take into consideration all the regulations from the grid company. We, of course, to win the contract, we had to have a very efficient vessel, and safety is always important. So after understanding this part, we moved on to see what kind of subsystems should we focus on. We know that there will be battery systems. We should have auto crossing functions. There was a huge challenge on the charging system, because there was a very weak grid. So we need to be in very close contact with the grid provider. So dealing with all these subsystems, then we can start to build the system based on the blocks that we have very good experience on, all the way down to transformers, generators, batteries, and automation system. We are located in the heart of the maritime part of Norway and on the western part. So we have offices in Ålesund. The main office is in Bergen, and we also have a department a little bit south of Bergen in Egersund. Just so that you can understand how the development have been in Norwegian Electric Systems. This is just back to the 2008, but where we had the automation system and the power management system that was then licensed. In 2010, we delivered the first quadro drive, which is based on converter technology. Some blackout safety system, remote assistance system. And in 2010, we started with system integration. mainly for offshore vessels at that time. But based on the converter technology, we made a good success in delivering a lot of systems to offshore vessels, which is quite advanced technology, all the way from DP system and so on. Bridge system in 2011, and a very special ring net solution in 2011, before we jump all the way to 2016, where we delivered the first battery container for a retrofitting on an offshore vessel. At that time, battery was of course important, and battery is based on DC, not AC system. So we had to use our experience in the converter technology, and we developed what we call a quadromaster, which is the DC switchboard in all the electrical ferries. DC has a challenge when it comes to short circuit, so we had to develop a safe system just in case you have a short circuit. And we have the approval of what we call the Odin's Eye, very Viking, but we are from Norway, so you have to excuse us. So that is the way that we connect the DC switchboards in a vessel. In 2018, we launched the auto crossing function, and our first all-electric ferry went into operation in 2018, which you can see on the side here. Moving into, for a marine company like Norwegian Electric System, moving into or on land and start talking to the grid provider, that was a very exciting experience, because we do normally we make our own power plant on board. So the two different environment, if I can say that, talking to grid providers coming from very fast acting company like Norwegian Electric System, that was very exciting. We learned a lot from each other, and it was very exciting to see that all the younger engineers from the grid companies, they moved slowly, very much towards what we were thinking, because they were just coming out of school, and all the technology that they have learned in school, suddenly they could use it. So that was very interesting. So we delivered the first charging station in 2018. By that I mean it then went into operation. And then in 2020, as I'm going to go a little bit more deeper into, was our development of a short charging station for very weak grids. In 2020, we also launched what we call the Raven ENS, that is an integrated navigation system built up from the bottom, which is a future-proof system moving towards autonomic operation of a vessel. So that is what we call the connected vessel. It's everything from cloud-based system to advanced radar technology and auto crossing, auto docking, and everything. Further on, just a little bit, it's in 2023 we will have the first pilot integration of hydrogen fuel cells on one of these coastal routes that is going all the way from Bergen to Kirkenes, so that the vessel will be able to go for at least 10 hours with zero emission. For now, it is the largest battery installations in a typical RoPax with more than 6 megawatt-hours of battery, so they can, even without hydrogen, go into this World Heritage fjords in Geiranger with zero emission. For this specific presentation here, where Fjord 1 has won the competition on operating a route between Fedje and Sæverøy on the western part of Norway. If you can see the map here, you can see Bergen on the bottom side here, and where you see the red arrow, that is the island where this ferry is going back and forth from to the mainland. Normally, we receive a integrator specification. In this case, we had a very strong cooperation with the designer, so we also had the opportunity to influence the system integrator specification. It started up in late 2017 when we received the possibility to look into this. It was already known technology on the vessel side. We had already experience from 11 electrical hybrid ferries at that time. But one challenge became very clear, because the charging requirement for the ferry was 2.1 megawatt charging from shore. And as you can see from the Fedje port, where the local grid company only could provide us with just over 300 kilowatt. So it was a very weak grid, and also the cost by strengthening the grid would be too high. So we had to find a way how to deal with this. This was not the first time that we looked into having also batteries on a charging station. But normally we saw that the capacity from the grid at least was 50% of the charging requirements. So we didn't need any special technology on shore. It was just to have a boost from additional batteries on shore to reach the required charging power. On the ferry, this is just a simplified one-line diagram, which is very typical for what we have delivered before. So excuse me if it's going to be a little bit complicated, but I hope everybody can see some known technical things here. You can see the two propellers, two thrusters. They are driven by a frequency converter from each side of the DC switchboard. As also we have talked about earlier today, we have a backup system with two generators going on biodiesel, also connected to the DC switchboard. So you will be able to run the diesel generators on a very optimal way. You need, of course, to have lights and other things on board, so you need an AC system, and that is also delivered from the DC system here through a converter, so that we create a 220 volt of AC system for the typical equipment like lighting and so on the vessel. And then on the top side you can see the charging plugs, and the batteries are connected also through into the DC switchboard. You can see on the lower side there. I think that the amount of the battery capacity here is just around 1.5 megawatt hours of battery, and for the redundancy part, it's divided into two different battery rooms. So the picture here is the vessel, 50 cars. So a typical double-ended ferry in Norway. For the charging station, you can also see here the one-line diagram, where on the left side, that is where we have the high voltage coming in from the local grid provider, and it's stepped down to 400 volt AC system, which this is not a part of our scope, but from here, that is Norwegian Electric Systems scope. So we have a 400 volt AC switchboard with the possibility to take out 400 volt to all the control systems and also for like normal shore power during night and so on for the vessel. So what we did is that we tried to separate the local grid completely during charging to rectify the 400 volt into the DC system. In this part here, that is where our system talks to the local grid's system. There are requirements from the local grid based on what we it's how weak the grid is. If you need to have a capacitive or inductive way of, like when the local grid is seeing our system and are going to provide 310 kilowatt, we need to use our knowledge within the converter technology to adjust the level of this cosinus phi that is a requirement from the local grid provider. Normally that is done on the ferry, but in this case it's done on the shore charging station. So the DC voltage is then supplied to the DC main switchboard, where also the batteries are included, and a converter then to convert the DC power to AC. Because of the technology and the level of or the state of charge of the batteries, the voltage will vary. So to be sure that we are providing 690 volt over the charging plug, we have also introduced what we call a booster here, just to boost up the voltage. So then we are able to provide 2.1 megawatt over the charging plug, which is the requirements from the vessel. In this case here, there was used a Cavotec charging solution. Sorry to my friends in Stamon, which is also listening now, but that was partly the owner's decision. And this is just a picture taken from the factory acceptance test in the factory for Cavotec. Everything here is delivery from Norwegian Electric Systems. So and also the responsibility that everything works and in connection with the ferry. So a typical operation will be that the ferry is coming into the port. It will be established a contact between the ferry and the charging station through Wi-Fi, and we are doing all the checks in the charging station. The charging station is also receiving information from the local grid company, so everything is then prepared when the vessel is coming in. And we have a connection time of around half a minute based on some criteria. Of course, safety is very important. And then the ferry is connected, and we ramp up the charging capacity within approximately 15 seconds. That is also this ramp up time, and ramp down time is also in cooperation with the local grid company, even if this is completely separated. But for a normal operation, for a normal charging station, that is a typical cooperation between the ferry system and the local grid company. So the result here is what you can see now. It's very tight, and it's This picture was actually taken yesterday, where you see the ferry is coming in here, the charging tower. This is just inside the equipment room on the port side, where you can see the batteries here, and this is I don't think every component is shown here, but you can see the DC switchboard and AC switchboard and some transformer here. Still, there are requirements for safety on shore, because we know that if especially the batteries are caught on fire, that will be hard to stop. So we have special systems for handling fire and so on in a separate battery room, also on shore. And here you can see Fadjebjørn, which is the ferry, is now connected through this charging plug here. So this is moving up and down because of the tide water and so on, and it's done by radar system, so that you will have a smooth connection through the ferry. I'm not sure if there are any questions. I guess maybe that will be at the end here. I hope there is a lot of questions. So because I think that was the final slide for now. So that was it. Any questions?
Thank you very much, Sten Ruben, for your presentation. So, are there any questions from the audience? Okay. So, yeah. So, the first question that I see here is it's about on the cost side. If you move on to having kind of a series of ships produced, do you see any financial effects, scale effects? So will the technology, I think this is what is behind maybe, because of the more application, will it become cheaper in the future? Do you see
that? I think everything is related to volume. So we will probably see a price reduction for the batteries, just like the car industry. It's based on volume. I think now the marine part of batteries that are produced are approximately 1% of the total production of battery. When there are more ships, the demand for batteries on a ship is of course way higher than on a car, where you have a typical Tesla of 75 kilowatt hours, and like I mentioned here, this is a typical 1.5 megawatt hour. So I guess you will see a price reduction on the batteries. When it comes to the power electronics, that's often related to steel and other material, and I think that will be quite stable. There is of course a competition always between suppliers for different equipment, but I think that will be more steady and more related to the copper price and steel price and so on. But everything related to software, that would probably be a different ball game. It takes a lot of money to develop new applications, but that will be of course cheaper when you have more competitors coming in with the same solution. Typically, we see that for some requirements now on the offshore sector, where there is something called a digital twin, where you can simulate everything on shore directly from the vessel based on sensors and cloud systems. But then you can actually do all the settings at the main office and transfer all these settings to the vessel, making the vessel maybe available to or possible to stay in a DP operation 15 minutes more than normally you would do if you were do anything manually on the vessel. And that is quite costly at the moment, but it's rather new, and you will probably see a reduction in that. So in the future, you will probably have the possibility to control the vessel and all the settings to have the most efficient way of operation through the home office.
Okay. I hope this question could be answered. Two more questions here. It's related to the batteries, which you are also, of course, responsible for as the systems integrator. What are the requirements, for example, DVN type approval or safety integrity level for batteries in your applications, electric ferries and boat? And also, what battery price do you expect from the market in dollar or euro per kilowatt hour?
The requirements in the DNV GL, it's based on two different. You have the two different notations. So it's a battery safety notation, which is requirements for all vessels that are having more than, I think it's just changed now, more than 20 kilowatt hours of batteries installed. Then you need to fulfill the battery safety notation. And you have also the battery power notation, which will come on top of the safety requirements, and that is if the batteries are connected to the propulsion part of the vessel. Going deep into details, it's about the safety aspect, of course, is you need to have a special battery room, which fulfills, I think it's called a B60 requirement. The battery should, or the room should be able to withhold the temperature and the fire in the battery room for 60 minutes, with the fire extinguish systems also included. It's a little bit about how the fire could be put out with either using Novak gas systems to reduce the oxygen level in the battery room. It could be water system, spraying system, and also some flooding system at the end where you just flood the complete battery room or container, if that is so. And then there is also requirements for how to monitor the system. It's a requirement that you have a battery management system, which is measuring the voltage and the temperature for each pair of battery cells. And there is also a requirement that the battery supplier has shown a propagation test, saying that if you have a fire in a cell, it should not propagate to the next one. Or in some cases, you could have some rule saying that if you have a module that is caught on fire, it should not spread to the next module. It's all about energy. It's a lot of energy in each cell, and it's even more in a module consisting of maybe 24 or 12 or 48 cells. And then ventilation, you need a special exhaust pipe in case you have a thermal runaway, so you avoid having gases coming into the battery room, but that would be led through the exhaust pipe out from the batteries and so on. I think that is at least some of the rules that the battery supplier needs to fulfill. The prices for batteries, for now, there are some, there varies a lot depending on the cell chemistry, because NMC chemistry is probably the most used one. So I can provide you with a range. It's let's say it's between let's say $700 per kilowatt hour, give or take some percentage. If you have LTO chemistry, they will be more expensive. If you have some iron chemistry, which is a more energy-based cell, that will be a little bit lower than the NMC typical part. But don't arrest me on these prices.
Okay, and there is another question related to this, so to this price, and how do you expect it to develop in the coming year from this level that you just described?
There are different graphs you can look up at internet. Most of them are related to the car industry, where you can see probably a drop down to just for the cell, which is half of the marine battery package. I think that some of the graphs show that you will have probably a cell cost of around $150 per kilowatt hour, but you need to add on everything that makes the vessel or the battery system safe, also in a car, because there are not only the cell. You have all the packing and how to handle the gas and the measurement of the cell and so on. So it's very hard to say. And also there is a new technology coming in for solid state batteries that will push up the price again. So it's hard to predict. But for a typical NMC, I guess you will see a 20-30% reduction within the next 5 years. Wild guess.
Okay, so before maybe we can at the end of your session here also look a little bit into the future and future developments. One more question here, and that was so Klaus Schneider would like to know what is the displacement of the ferries that you talked about, and the power of the two electric motors, and there's also the questions if they are asynchronous or permanent magnet.
The displacement of the vessel, I need to check out with the designer. So I don't have the answer. I think the power of this vessel is 900 kilowatt, and it is a permanent magnet motor. We see most of the thruster suppliers have engaged with the supplier of permanent magnet motors, and normally they are integrated into the thruster in a very good way. So there are, I think 70% of the system that we have delivered is for permanent magnet motors, and the rest is for asynchronous motors.
Okay, yeah, let's maybe go away a little bit from this Fjord 1 ferries and in two other fields that you are also active in the end of this slot. So one thing is that I understand the Fjord 1 ferries, they were new buildings, so you could develop the systems from scratch, you can say. On the other hand, you are also involved. We see in Norway that now this LNG ferries, which like 15-20 years ago were kind of the first ones to have a little bit of green move in the market, are now retrofitted into hybrid and battery electric ferries. So can you tell us more about this? Is this an Under which circumstances can that be an interesting option for operators?
Of course, because of the regulations and also the new requirements told by Anders that zero emission will be the future for ferries. It's a little bit pity, of course, that we have very good ferries going on LNG, which is not fulfilling the new requirements. But it's of course it's a possibility to use the hull, and we have experience now by retrofitting four vessels already, which is previous LNG ferries, where we participate through the yard, removing the LNG tank, and suddenly you have a lot of space to install battery systems. So the typical way is that we go on board, visit the vessel, we do investigation on both the automation system, on the propulsion system, and the AC system, what can be reused, because a 10-year-old, 15-year-old ferry still have a long way of living. So normally it's actually there are two ways. We can either connect batteries directly into the or not directly, through something that we call a Quest system, which is taking the batteries and we make AC system of that, and we also have the charging system connected into this part. Or if it's a little bit older vessel, or it's more complicated to just use the existing AC switchboard, we can actually take out the complete AC system and install the new DC system like it was for a new building, and then either do an upgrade of the automation system. Normally it's quite advanced system already because of the LNG system. So in 50% of the cases we do an upgrade of the existing automation system, and sometimes we also take out the old one and install a complete new one. So this has been done both for all electric ferries in Norway and also for the TS Lavad ferry in Estonia, where they were prepared for LNG, but they never had LNG installed. So for one of the ferries, Tull, we went on board and installed a Quest system into the AC system. This is not a plug-in ferry, so it's just doing peak shaving, and we are optimizing the running hours of the diesel engines and so on. So there are different ways to do that. It's not new for us.
Okay, so hybridization to certain extents, different extents, I
Yes.
understand,
Yes.
depending on the operating profile of the ferry. So one last question. I think when we look at that, you mentioned it also that, for domestic short distance ferries, battery electric propulsion is kind of, is already a mature technology with some, like Anders pointed out, challenges and development and research, maybe also demand when it comes to the connection to the grid. If you look a little bit further beyond the car ferries and passenger ships, you mentioned that your company comes also from, or is also active in other fields of maritime transportations. Where do you see also other use cases for battery electric propulsion systems in ships? What do you expect there for the future? What could come up next?
There is a big discussion now, and also movement towards what what Edmund will talk a little bit about for passenger ferries, fast passenger ferries, could either be for batteries or hydrogen. That will be exciting to see, and also everything related to the fishing industry is also for the smaller vessel that is going out to all these fishing farms. That will probably a zero emission part, or smaller, like this brim, where you have exploration and tourist vessel. And there is now a movement also to look at the short sea shipment, where you have smaller bulk vessels that are having a lot of harbor operation. That will also be interesting to see how much you can do only using batteries, but we participate, or we will see that the hydrogen part will move also into the short sea shipment segment. So there is 2 tenders now out. So for bulk vessels, around 5,000 deadweight tons, that will be running on some kind of hydrogen or other zero emission solutions.
Okay, so I see there are no further questions from the audience. So thank you very much, Stein Ruben, for your presentation and going with us a little bit deeper also into the technical aspects of battery electric propulsion systems, and having also a little bit of look into the future. So then we will proceed with the next presentation. And here, I mentioned it in the introduction, we will go again to a different kind of vessels, and we will get to know the world's largest plug-in hybrid RoPax ferry, the Color Hybrid, so which is in operation since 2019, and which can go parts of the journey fully electric. And I'm very glad now to give the floor to Robin Tomreen, Executive Vice President at Colorline, for telling us more about the design of the Color Hybrid, and also about, I would say, the first experiences, because I understood also that the operation was a little bit disrupted by COVID in the last years, the first experiences with the operation of this very impressive, and I must say also very beautiful vessel. So please, Robin, the floor is yours.
Yes, Jens, thank you very much for the invitation to this interesting seminar. And I will try to give you an introduction of Color Hybrid. As you mentioned, Jens, here we see the vessel. We will take a journey with this vessel now. We're leaving the port of Sandefjord here, and we set this vessel into operation the 15th of August 2019, as you told, Jens. That's correct. And but unfortunately, the 14th of March 2020, the vessel was stopped due to COVID-19, and it has been more than 14 months now out of operation due to COVID. So that's not good for a new vessel, and we're really looking forward to get the vessel back in operation, hopefully within not so long time. So that's given us some limited operation experience then. And we took over the vessel from the shipyard with a lot of outstanding remarks, and we used a lot of the first months in operation to get the remarks solved, really. And it was first in the last months we was really able to operate how intended with the vessel. But I will tell you a little bit about why we ended up with a hybrid vessel. If I go through the technical data about Color Hybrid, a little bit about operational modes and energy saving initiatives taken. during the design and operation of Color Hybrid. Yeah, first the journey or the route Color Hybrid is designed for is the Sandefjord-Strømstad route. That is a pretty short route. It's only 38 nautical miles. The timetable is set for 2.5-hour crossing time. Is some speed limitations in both ends in the narrow waters, and due to maneuvering time. So, but the average transit speed is only 16.78 knots in open water speed. Yeah, and it have a short turnaround time in port. So efficient loading and unloading is an important part of the design. Yeah. Yeah. Oh, sorry. Let me see. Yeah. If we go into the power plant configuration of the vessel, yeah. If I can make. Yeah. It starts with it's a twin screw vessel, conventional CPE propellers connected to a pretty advanced gearbox. There we have 2 diesel engines and 1 PTO PTI, so both can propel the vessel, or it can produce electricity, so connected to the gearbox. And we have also DC switchboards as shown by Norwegian electric system as well. Battery systems. We have the batteries connected directly to the switchboards. We have the shore connection, and we have also HySeas switchboards, of course. We have about 1690 volts shown here, and also down to a 230 volt switchboard system. We have 2 tunnel thrusters in the bow, conventional tunnel thruster connected directly into the DC grid, and 1 rim tunnel thruster in the stern. That was to really increase the efficiency of the vessel and the design to get a very slim thruster into the skeg. So there we selected a rim type stern thruster. Yeah, without any center hub, and there the propeller blades are connected really directly connected to the E-motor. That is a ring that is part of the hull. We have the battery banks as we told about here, but we also have, not shown in the drawing here, a huge heat reservoir that we really store the same amount of energy in the heat reservoir as we do in the batteries. And this vessel is only a day ferry. It's operate approximately are in operation 14 hours per day, but the diesel engines are only running 8 hours per day. But due to the heat reservoir, we shall be able to be collecting more or less all the heat we're able to get out from the diesel engines, and we have heat enough for the vessel during the whole day and night without any additional using any additional energy. And we was able to adding this heat reservoir without adding any significant extra weight or on the vessel by using the healing tanks that the vessel have anyway for compensating for during loading and unloading of heavy loads. So what we have done is to isolate up the healing tanks and using they as heat reservoir at the same time as they function as healing tanks. Yeah, and the vessel have 2 a little bit larger and 2 smaller diesel engine and father and son arrangement, and for design speed in open water, the vessel is designed to go only with 2 engines. So we have a huge flexibility here. Depends on the weather and the routing and the timetable. We can operate on 2 small engines, 1 big, 1 small, or 2 big ones, or even all 4 if we're interested in that. So we have a huge flexibility. And the vessel have 4 sources of energy. Then we try to say we have the diesel power, we have the shore power, So we're using when we are on shore, and we have the batteries, they are charged by shore power, and we have the heat reservoir. Yeah. Yes, the vessel is a Norwegian flag vessel designed for international voyages according to SOLAS, and have both probabilistic damage damage stability requirements, but we also voluntarily fulfill the SOLAS 2020 damage stability. We are one of the first passenger vessels in the world fulfilling that requirements. Yeah, that's only required from vessels contracted after 2020. Yeah, and we also have the safe return requirements fulfilled on this vessel, and that sounds simple, but that's really complicating the design of the vessel a lot, and give a lot of special challenges to consider. So and really, to be frankly and straightforward, for this coastal operational, we think the safe return to port is really not increasing the safety a lot, and I think other requirements should be in focus for this coastal operational vessels. For deep sea crossings and Atlantic crossings, the safe return to port adding a lot of additional safety, but it's a little bit different than for the coastal operation. Yeah. The main dimension of the vessels you see here, and it's have a certificate for 2,100 persons on board. Yeah. And really also one of the things we are doing to optimize the energy consumption. The vessel is designed for the operational speed and not for the max speed. I think we lost, if we have taken out the propellers and everything for max speed, we have had more than close to 2 knots extra speed, but we have optimized for minimum fuel consumption during the design speed. Yeah. The vessel is built as a conventional RoPax ferries with 2 car decks in the bottom, and one hoistable deck on the starboard side on the casing here. So it's and a fixed car deck on the 5th deck. Yeah. This is the first vessel we tailor-made for this special route between Sandefjord and Strømstad. This is very much a shopping route, so the whole 5th deck is a shopping deck. So it's really 2 big shops, the whole 5th deck. And really here in the stern we have increased and have a 2-deck high shop here in the stern. So that's going over 2 deck here, and the 6th deck is a restaurant deck. And since we have taken the aft part here for the shop, we are also lifting the restaurants up to the top deck here in the stern. And the 8th deck is where the crew is living, and we have the sun deck on top. So that's a classic ro-ro design with double-ended ferry with loading and unloading in both ends. Yeah. Yes. Of course, this setup, as I presented in the previous slide, giving a lot of flexibility. When we have 4 diesel engines, 2 battery packs, we have 2 clean generators for electric power generation, and we have 2 combined PTIs. So yeah. So I will take you through some of the most common used operational modes during operation of the vessel here. Of course, a lot of the time we are in port, and then we are connected to the grid through the shore power switch, and it's supplying the shore power here. We are charged shore power with 3000 volts. We transform it down to the voltage for the main switchboard, and drive through a converter to DC, and supply the DC switchboard with shore power. high voltage shore power, and we're charging the batteries. So the design principle here, and the batteries are charged only from shore power. Yeah. We disconnect the shore power connection and start up all the propellers, the tunnel thrusters, and the main propellers fully electric. And we shall maneuver from the port in Sandefjord. Yeah. And at the same time, of course, the batteries also supply down to the 690 and 230 volt switchboard here. So also the batteries supplying the hotel load. And of course, after we have maneuvered out from port, we turn off all the thrusters and continue sailing fully electric with power from the batteries through the PTI on the main gearbox. And we are sailing in the coastal near water with batteries, and after we come out in open waters, we start up the diesel engines. It's happened seamless, and here we see it's selected to start up a small diesel engine on one side and a big one on the other side, and one 6-cylinder and one 8-cylinder. And then the propellers are run by the diesel engine, and we supplying the hotel power from the generators. And we're using, of course, the batteries active to peak shaving and to spinning reserve. So the net flow to the batteries should be 0, but it's flowing a little bit out and in, depends on the peak shaving function. Yeah. And of course, we're coming into maneuver in Strømstad, and we are in the same mode. We still run the same engines, and we're starting the tunnel thrusters, and the batteries can supply us power as needed as well. Yeah. Yes. So we for this huge vessel compared with the domestic ferries, we supply approximately 20% of the energy consumption from shore power during the sailing here. And we looking forward. We have a very good grid here in Norway, and especially in the port of Sandefjord, due to old industry here. So we have the possibility to charge with up to 6.5 megawatt. So we have due to the power grid here in Sweden and Strømstad, we don't have the same possibility at the time being, but we're looking forward also there to be able to get charging there, and then we can increase the energy used from the batteries to sailing on here. And the vessel is able to sail up to 12 knots for 1 hour, including the hotel load with the battery powers. And the weight of the battery package is 65 tons, and the batteries are placed far down to the bottom of the vessel for the stability, and also far out to the ship side, so they increase the mass moment of inertia of the vessel and reduce the rolling movement of the vessel a little bit. So we have here. So here is where we see the batteries are placed, and it's placed over two decks in here. And compared with the main engines, here we see the 4 main engines as well. So you can compare the size of the batteries. Yeah. So we transfer energy consumption from diesel to use green energy and shore power with the batteries, and that's of course reduce the emission of NOx, SOx and SOx and particles during the coastal operation. Yeah. And as mentioned, the batteries are used for peak shaving and help us to optimize the optimal load on the diesel engines as well. We use them as spinning reserves, so we don't need to run any additional diesel engine. And we have also taken away all the auxiliary engines on this vessel due to the batteries, so they only have main engines. Yeah. Yeah. And of course, the batteries are connected to the switchboard all the time. So if a sudden drop of a diesel engine shall happen, or a fallout of a diesel engine, the batteries are there and have extremely good dynamic load response. So even as a quick load change or a dropout of a diesel engine will not inflect the electric power grid on board the vessel. Yeah. And here you see a typical example of peak shaving. You see the normal load of the diesel engine, and here you can put the diesel engine into a constant load a little bit above 1 megawatt, and the batteries is delivering a little bit and is charging a little bit. Depends on how the power demand on the vessel vary with the time. Yeah, if we look into the battery cycle of the vessel, it's a little bit simplified here, but the vessel coming in late in the evening. So if we start here at midnight, we're really starting to charging a little bit before midnight. But to simplify it here, we say we're starting with midnight, and the vessel, the batteries are fully charged till 7 o'clock in the morning. The vessels, that is to have a little bit the margin here. If something happened with electric dropout or anything during the night, we have some margins in. The vessel is start moving from the night position and moving over to the ferry berth at 8:45. So then we using a little bit battery when sailing the vessel into the Ro ramp. Yeah, and then we're charging that up again during the time the loading the vessel, and take on board the trucks and passengers, and then we're sailing fully electric the coastal area in at the Norwegian side, and then we starting up the diesel engines. The batteries are used only for peak shaving. That so the charging state of the battery is pretty constant during the sailing. We are in Sweden, unloading and loading again, and transiting back, and we coming into the coastal area, and we stop all the diesel engine and is sailing into port in Sandefjord again, and we shall be about 20% left battery capacity when we arrive in port. We plug in the high volt connection, and during 40 minutes of charging, we are charging up the battery again, and we start and repeat the same circle again one more time. So the vessel is doing 2 run trips, also 4 legs per day. And yeah, so that is how we're utilizing the batteries. As I told you earlier, we have a large heat reservoir on board as well. And even in Norway, it becomes so warm a shorter period in the summer that we can swim in the sea. And then also it will say that we don't have so much need for heating on board the vessel, and we have also air condition needs on board. So we have also installed an absorption chiller on board. So during summertime, when we don't need the heat reservoir to heat up the vessel, we're running the absorption chiller that using heat really to produce cooling. So with adding 3.4 kilowatt electric power into pumps, we are able to getting 720 kilowatt of cooling capacity out from the absorption chiller. This is not a petroleum mobile, as you know, so we're adding more energy, but we're adding a lot of heat energy here as well, but that is free energy that we have on board. So we see this is also one of the additional technical installations that have been done added to this vessel to reduce power consumption. So this was the trip from Sandefjord. Now we start to arrive Strømstad here, and this was what I have planned to say during this presentation. So is it any questions?
Thank you very much, Robin, for this insights into the design and also the operation of color hybrids. So, are there any question? Yeah, there is one question, but this is yet a bit too short to understand it. So it's from Mr. Schlickum. Maybe you would like to ask the question yourself. You can enable your microphone and do so if you like.
Oh, was not a question, was respect for the complete package. It looks really good.
Yeah, it becomes a really advanced package, to say it that way, and yeah, we're adding a lot of new technology into this vessel, and yeah, you also see on experience during the construction of the vessel that yeah, you also need to try to keep the vessel a little bit. We added in all the flexibility we was able to do during the design, but we see it become very, very complex. And maybe if we are yeah, thinking forward, we see that to really optimize on the operational modes and see what flexibility you need to have, because it's complicated also for the crew on board to use when you have all the options available all the times. Yeah.
There are some questions about batteries, technical questions. One is, what is the battery chemistry, and also what is the estimated battery lifetime?
Yeah, I can answer the last questions first. Yeah, we have designed and the battery package to with a guaranteed lifetime of 10 years. So we expected to have 10 years or more, than a little bit more. We was only expecting then from the lifetime of the batteries. Yeah, it's the chemistry of the batteries. Yeah, it's Siemens batteries on board. So yeah, I'm not on top of what you call the chemistry of that, but it's Siemens that have delivered its water-cooled batteries we have installed here. Yeah, from Siemens.
So how do you define the end of the lifetime? 80% of initial capacity? That was a follow-up question.
That's correct. Yeah. So that's why we have some additional capacity here to have it's 80% of remaining capacity at end of lifetime. Yeah.
Okay. There is another question. So you are operating the Sandefjord Strömstad line with 2 ferries, and you have also other lines as color line, this cruise line from Kiel to Oslo, and then also this Hirtshals Kristiansand line, which is a bit more cargo oriented, as I understood, while this line is a fun line, I would say, shopping line also, and Oslo Kiel is very much a cruise line. So if you look into the future, I mean, yeah, very difficult conditions, so it's not the time to make plans, but do you also see use cases for hybrid propulsion systems on your other lines and your other ships?
Yes, absolutely. Yeah. Shall we be able to meet the Paris agreement and keep the global heating of 2 degrees Celsius? I think the whole shipping industry need to do something. And yeah, the MPC 76 meeting in IMO is happening also as we speak today, and hopefully we're able to conclude on Thursday this week, and there the rules and how the international shipping shall reduce their CO2 emission or greenhouse gas emissions hopefully will be settled. We think, yeah, not 100%, not everything will be fully settled during this week, but a lot of it, hopefully. And then we need to also include the other lines, and we are looking deep into other fossil-free fuels, and ammonia is something we have studied a lot for the Oslo-Kiel route. We see ammonia is a very for deep sea shipping on the long routes. That's probably a very interesting and promising fuel. We have hydrogen. We are looking a little bit into this medium to short routes, and I fully support Statens vegvesen as presented in the starter, electric and really use of batteries, and really to extend the use of batteries to longer and longer routes. I see from an energy perspective, batteries is sailing up as a very good candidate. But yeah, but for the medium routes, we need to look into other energy storage systems. And about hydrogen, we have ammonia, we have biofuels, and other synthetic options as well. So we are studying. Yeah.
Hope that this question was from Marek was also answered with this. Once again, there is a question about the batteries after the 10 years. What do you plan to do with them afterwards, and do you have a plan for that?
Yeah, we don't have a too detailed plans, but not yet. We expect a lot to develop with both the recycling of batteries and extended lifetime and that stuff. So we have been into discuss both these options, and but we think at least we're adding some new, fresh batteries during this period. We will extend the lifetime for more than 10 years. It can absolutely be likely, but then we're going for extend program. But I think a lot will develop during the next 8 years forward from now. So I think it's far too early to take any final decisions on that. Yeah.
There was a question again on the future, and also you mentioned already that battery electric systems can be an option for short distance routes and also maybe for the medium distance routes. So, and there is a question then, just for speculation and your opinion, when can fully electric ferry could be ready to cross the Baltic Sea, for example, from Poland to Sweden, which would be I think 6 to 8 hours journey. Can you imagine that this could be an option in the future, or would you then rather go for other technologies here?
Yeah, I think that's absolutely possible, and I think it will not be that far away either. I think within 5 to 10 years time, I think that can be possible. It depends how the world is developing, but and how the battery technology is developing is one thing, but also how the cost of energy and use of energy is developing. And of course, if we giving ourselves a little bit more time, to say it that way, and can travel a little bit slower, because we know that speed is also very energy demanding on the displacement vessels, at least. If we are able to reduce and can use a little bit more time on the travel, I think it's not that far away before we can travel between Sweden and Poland fully electric. Yeah. Yes.
Okay, so that was a look into the future. We are a little bit shortening our coffee break, or grab a coffee break already, because there are so many questions and so much discussions. So yeah, thank you very much, Robin, for your presentation and also for answering all these questions. So yeah, I would suggest that we now take our grab a coffee break that we truly deserve after more than 2 hours. And yeah, I would suggest that we make it a bit shorter, and that we will try to be back at the planned and scheduled time at 11:15. And then we will have a look into the first all-electric driven fast ferry, the Medstraum, that is under construction at Fjellstrand, and Edmund Tollo will be the next presenter. So thank you very much, Robin. And yeah, so let's take a short rest now before the next presentations. See you later. So welcome back to our ELMA online seminar with revisiting Norway, next generation electric ferries and passenger ships. And as I told you before, we went into this short and even shortened coffee break. We will now have a look to another interesting project, which is not yet reality, but on the way to become reality. So key laying was just last week. And that is the Medstraum, the world's first, it will be the world's first all battery driven fast Pax ferries in accordance with the HSC regulations. And I'm very glad that today, as 3 years ago, we have again Edmund Tollo with us, sales manager at the Fjellstrand shipyard, which is, you can say an innovator and pioneer in the field of zero-emission car ferries and pack ships, which also delivered the world's first all-electric car ferry, Ampere, and which is now going into these new projects, which goes into a different type of vessel that also Stein Ruben already said that will maybe get more and more into focus in the next year and could become an interesting segment. And yeah, Edmund, so the floor is yours. Please tell us more about Medstraum and the tram project.
Thank you very much. It's a quite interesting project that we speak about here, and I hope first to share this. Sorry, I shared the wrong screen, I guess.
Yes, this is the wrong one.
Yeah, I'll try again. Yeah, now I hope you can see what we. It's not much to see of what we are doing there, but still we have this called tram, which is then short for transport, advanced and modular. So modularity in the building is part of this project. Now you can see a bit of what we are talking about here. It's a battery-driven passenger vessel. It will be 31 meters length overall. It should have a speed of 23 knots and enter into operation for Columbus. This will be the first fully electric fast ferry, and fast ferry then defined by fulfilling the high-speed code. Just to talk a bit about what we are doing at Fjellstrand, we have a long history of fast ferries. So in the 80s, what you see in the lower left corners here, you will see the fast ferry, the 40-meter Flying Cat, with which we built quite a high number of, I think more or less the same design for 33 vessels shown in the lower left corner there. In the 90s, we developed the Foil Cat, and we still have 2 vessels operating in between Hong Kong and Macau with a speed up to 45 knots. Then in the middle there, you can see the Ampere, and the first large aluminium ferry we delivered was in 2002, when we delivered a double-ended car ferry for 120 cars, which these ferries were built on design-wise. And then you can see in the lower right corner that we also work within the windmill industry, both with the steel vessels and also with the trimaran that we have delivered 6 vessels from. And then we also have the last ferry that we have delivered, the Kommandøren, which is an 87-meter long aluminium ferry. Since we are talking about electric ferries here, let's continue with the Ampere that we delivered in 2015. This Ampere, the vessel has sailed about 70,000 kilometers per year. So it equals to about 10 times around the equator. So far we can say we have experience from the operation now, and we know a bit about the problems and the challenges, and also the opportunities in sailing with electric vessels. One ferry like this reduces, or this ferry reduces about 2,600 tons of CO2, which represent in average cars in Norway, it would be more than 1,600 cars that it equals to in terms of diesel consumption and CO2 emissions. We delivered also, I think some of you were actually on board when you visited Norway some years back in 2018, I think. You were on board this vessel and could see it by yourselves. It's an 87-meter long vessel that is now brought into operation between Våge and Halhjem, not so far from the yard premises. This one operates 24 times the 12.5 kilometer crossing between Halhjem and Våge, operates in the speed of about 13 knots, and with the capacities needed for this vessel, which is a route more than double the length of the route for Ampere, it's about 3 times the battery capacity and energy capacity needed for that operation. So it shows that things has developed, and the industry connected to this is developing constantly. However, the target we had that time, and I think I presented that at that time, was 25 knots, 150 passengers, and operations up to 2.5 hours. Is that possible? And we have now started our project with Rogaland County as lead, and we have got EU funding for this project, and yeah, as mentioned, we are already to the keel laying now. Just to mention again, what is the challenge? And the challenge is that we have about the same engine installation in a fast ferry as we have on a regular ferry, but with 1/3 of the length for such a vessel, half of the width, and then you can see in the area here, then the length is 1/3, area is 1/7, and the volume that we should place batteries and systems in is 15 times bigger on a ferry than it is on a small catamaran like this. Obviously, this will lead to quite difficult challenges in terms of being able to organize it and to carry it and to keep up the speed, since we are fighting weight all the time with faster speeds. This project is led by Columbus, who is actually our customer in this term. And you can see the funding was approved in 2018. Actually, in October, everything was finalized on around that, and we started the development process. The development process lasted until December in 2019, and we have, of course, worked not only on one test. We have continued the development there, and we have a production startup now. And in next year, we will have the delivery of the vessel. You can see here all the partners. Fjellstrand will build the hull and the complete vessel. Leirvik will build the superstructure. Wärtsilä is the system integrator. Servogear for propellers. HSVA in Germany is doing the tank testing, and we have some universities from Athens and Strathclyde helping us, and the modularity will be by Fraunhofer. Then Columbus, Rogaland is the customer, and we have some other projects that we will test also against the Thames Clipper in London and Flamse Waterweg in Belgium. The background for it is quite obvious. With only 4% of the travels being done by fast ferry in Rogaland County, they represent half of the emissions. The vessel is an all-aluminium vessel. We have designed it for using plates, extrusions, and friction stir welding panels in a modular building system. Front loading, which is safe and efficient berthing with direct view from wheel loads. All passengers on one saloon for good overview of passengers, and then it is for DMV class. So it will have the power notation, and it is in enclosed waters, so it's for service area 1. I will try to show you a short video.
Meet the future. Meet Medstraum, the world's first zero-emission, fully electric, high-speed passenger vessel. Developed through the EU-funded Tram project, this fast ferry is revolutionary, both in terms of zero-emission technology and manufacturing methods. While ships are usually designed as one-offs, the car and aviation industry have built vehicles for decades using modularization principles. In the Tram project, 14 European partners aim to transfer this Lego mindset to shipbuilding, making electric-powered, high-speed vessels more competitive in terms of both cost and the environment. Different modules have been created to be used across various application cases and operating conditions. Modular production methods will contribute to 25% lower production costs and 70% lower engineering costs. From 2022, Medstraum will operate a route in Stavanger, Norway, on behalf of public transport company Columbus. This will be the world's first fully electric fast ferry with zero emissions to air and sea, illustrating that modularization can and should change the way ships are ordered in the future.
I hope that was quite self-explanatory. And the modularization, I don't have to go into details. You understand what it's all about. We have Fraunhofer in helping us to develop such a modular thinking, where we think modularity not only in the building but also in the design, so we can pick sections and necessary functions out of it. The vessel safety consists of many systems, but actually I want to show you also that the arrangement is also quite important for the safety of a battery. And while normal vessels would have typically a failure mode effect analysis for its system, we have to establish a battery safety philosophy, which includes the space arrangements, the fire extinguishing, flooding, thermal runaway, hazardous areas, and so on. And we also need a shore connection philosophy and a power supply philosophy. So all these things are special for a battery ferry, and where we have to not only follow a rule, but to establish a risk analysis to study it. Typically, it's also for the battery that you might have to study also the route. So you cannot necessarily follow the route as it is today, because then you might have such dips that you use a too big battery. So maybe you need some additional minutes of charging, or you can reduce the speed, or you can change the route in order to avoid such low charging levels for the battery, so ensuring that you will have a battery that lasts for the 10 years it's supposed to do. Here you can see the harbor of Stavanger, where there will be charging facilities at Fiskepiren, where they will also in the future charge other vessels than this one. So they will have 8 megawatt capacity to be installed, while we are using about 2.3 megawatt of that one. Then example of safety through design is that if you have a side damage, for example, if you have a side damage, you will have seawater coming into the batteries. Normally, you have seawater coming in to the hull. You can avoid it by maybe putting in a cofferdam on the side there. But what we have done is to move the batteries up to the main deck. Then it's quite away from all the collision dangers and so on. We are away from the ship sides where you can have salty atmosphere for the intakes and so on, and everything is done on the top of the batteries to keep it away from the salt and sea and any dangerous parts. Yeah, that's what I was planning to say today. So then I would be open for questions.
Okay. Edmund, thank you very much for this introduction to this Trump project and also the Medstraum. Are there questions to Edmund from the audience? Now they are coming. One question is, do you have a concept for recycling of this ferry as well, not construction? And is this an investor's concern?
Then I think you should ask more on the battery suppliers. They say they have a concept for it. When we are the builder, we are not like a car manufacturer that we are a small builder. So we make a vessel where you have a possibility to change the batteries and trade in the used batteries as Corvus. We are here using Corvus Dolphin batteries. We are not into the recycling of that part, but Corvus is claiming that they can in the future recycle it. I do not have the plan for that, and we deliver the vessel to the operator, and the operator will probably use the vessel for 10 years before they are changing any batteries. And we are not involved at that part. They can then put in any batteries they like, but then it will be up to the operator together with the battery supplier.
See here another question. Is there also autonomous driving including in these projects yet?
Definitely no. There is not autonomous. Of course, you can technically do it, but to do it with 150 passengers is probably not the place to start. So it will come, and we are looking into other autonomous projects, but not for 150 passengers. Of course, you can run the vessel autonomous, and you can keep the safety personnel on board still. But this is not the part of this project.
There's a question about who will deliver the battery to this project. Is it Corvus?
For us as a customer, we buy the batteries through Wärtsilä. But the batteries are in this project. They are Corvus batteries. It's Corvus Dolphin power batteries, which then are delivered through the system integrator, which will be Wärtsilä.
Okay, so you mentioned that this is the first vessel, battery electric vessel, that will be classified according to the high-speed code. So the question here is, what were the specific challenges with this regard, and who was also your cooperation partner, and was this also part of this TRAM project, or is this something that is separate to this project?
I guess that in this project we are, as Fjellstrand, probably the only ones that has been working with the classification of fast ferries. So that part ended up on us. But of course, with the vessel classified as a fast ferry, you have to do a study on the risk, and you have to include a double bottom, for example, for the hull, a double bottom which takes away a lot of space in the hulls. So that means you don't have that much space left for batteries either. So that is a part of the reason why we have moved it up in the aft part of on deck level. Another thing is that for a fast ferry, all equipment has to be withstanding collision forces. So that means that the battery system then has to allow, I can't remember, I think it's 5.4 G that these all the big items has to withstand in the collision for this speed.
Are there further questions? You mentioned that part of the project is not only to make a fully electric fast ferry, but also to go into modular design of vessels. So here the question is, first of all, what use cases? So I understand that this vessel now is serving a commuter line, close to Stavanger. So daily the same passengers. So when you look at this modular design, so what further configurations and use cases do you have in mind for this fast ferry? And the other thing is that you also mentioned that in Stavanger there is a pier with charging yeah, that you use. So far we learned always that the charging infrastructure is very much tailored for the vessels. Do you expect here also some kind of standardization in the future?
Yes, we are looking at standardized systems, and what we will use as charging here will be a number of car chargers that we connect to keep the cost down, to make it in a modular system, and to ensure that even though the vessel could be moved to another place, we will still be able to have a charger that can be connected, and that we are using the same methodology as they are using in the car industry, that we are using the same automation systems and the same addresses for disconnect and so on for as they are using for a car. So then we have a certain way of possibility to standardize over time. I'm not sure I answered all the questions, and I think I maybe answered only one, but I forgot the first one.
The first one was about the modular design. So now it's a commuter
the modular
ferry.
design.
So what other configurations do you have in mind, and which other use cases do you also have in mind for this type of product?
What we are talking about here is passenger vessels. But the modularization will make it possible, for example, to change from a propeller version to a water jet version without big design changes. It will make it possible to make a longer vessel with only changing sections and such ways of already thinking of the other modules already in the design now.
Okay, are there further questions to Edmund from the audience?
I see somebody has asked whether the batteries probably was made in China, and no, these batteries are actually made in Norway. Corvus has a factory in Bergen, which is only 80 kilometers from our yard.
Okay, yes, that was one of the questions that was left. And yeah, I think the answer was satisfying, as I see. Okay, yeah, then, well, thank you very much, Edmund, for joining us again, and give us a little bit of an update, and good luck with the Medstraum project. So when will it go into operation? When can we come to Norway to have a test drive with it?
That will be next summer, I hope. We should deliver this in March next year. So then it's a question whether they will be ready with all the charging facilities in Stavanger. And if that is in place, we can then start the operation next summer.
Okay, yeah, let's hope that the conditions, the COVID conditions, will allow us to have a look maybe next summer. So thank you very much, Edmund, for your presentation and for your time, and hope to see you again at another meeting. Okay. Yes, so we are a little bit, of course, behind the schedule, and we come now to our last presentation. I would suggest that, well, we would have only some minutes left, but we come now to an interesting topic. So I would give the possibility to our next speakers then also to extend their presentation a little bit, so that they do not have to hurry. And of course, we may also have question and answers after 12 o'clock. If you should not be able to follow it to the end because of other obligations, I would also like to point out that there will be a recording of the meeting, so you could still follow the last part. If you have to leave earlier, that will be made available end of this week, beginning of next week on our website. So we have been in Norway so far, and now we have a little glimpse to Scotland. But as I said, there is also a lot of Norwegian expertise involved in this project. And we will have a look to the HySeas III project, the world's first seagoing car and passenger ferry with hydrogen electric propulsion, which is in the concept and design phase, which is likely to serve the Orkney Islands in the future, and which also not a project which also not only kind of focuses on the vessel, but also on the production, the local production of green hydrogen from renewable sources. So we will have two speakers here. We have on the one hand John Selton, Fleet Manager and Project Director at Caledonian Maritime Assets. And then we have on the other hand Christina Mikkelsen, she's a project manager at Ballard Power Systems and is responsible for the fuel cells that will be used. And as far as I know, I will now give the floor first to Christina for a presentation, and then John will tell us also add a little bit on the vessel design side. So, Christina, the floor is yours.
Thank you very much, Jens.
Like I said, take your time. Yeah, we can prolong the meeting. It's an interesting topic, so we do not have to cut at any point. Yeah.
Can everybody see the screen?
Yes, you are not yet in presenting mode.
There we go.
That's perfect.
That should be. Okay, John, I'm going to hand this to you for the beginning.
Okay, we cannot see you.
Thank you very much.
Okay, just please enable also your cameras. That would be, I think, very good. Okay, but now I will be quiet.
Okay.
Thank you very much, Christina, and welcome. Thank you for the invitation to allow us to present HySeas III. Welcome from Scotland. My name is John Salton. I am a project director with Caledonian Maritime Assets. We own 36 ferries operating around the west coast of Scotland and also the Northern Isles to Orkney and Shetland. We're very excited to be part of the HySeas III group. I do have IT problems, but Christina is going to move the slides over from one to one when I request, so apologies for that from my side. Christina, could you go to the next slide, please? Thank you. So HySeas III was put together following on from previous projects, and the main point of HySeas III is to put together a full shoreside testing facility for the drivetrain system. So going from the fuel cells, hydrogen plant, fuel cells, through the drivetrain used from Kongsberg, the power integrator, and then eventually through to a load bank, and there'll be batteries in parallel as well. This would be basically what would be fitted on board the vessel. Caledonian Maritime Assets, for our part, are doing the design of the vessel, and the equipment which is at present been tested just outside Bergen, the intention would be to utilise that equipment in the vessel design. We would also, from the experiments that are taking place in Norway, disseminate the information back to EU and partners around Europe as well. Next slide, please, Christina.
Yep.
So as mentioned, the project combines fuel cells with batteries in a typical ship's load scenario. We have looked at the vessel running from Shappensea to Kirkwall in the Orkney Isles. It's a small trip, but it is a seagoing trip of 4 miles. It's a lifeline service to the island of Shappensea, and the vessel does around about 9.5 knots. We'll be looking to carry 120 passengers, 16 cars, or 2 HGV vehicles, or a mixture of both. And the powering for this new design vessel will come from Ballard fuel cells. The likelihood is it will be the FC Wave, which is presently undergoing classification approval. Next slide, please, Christina. And just to explain, we are new to the consortium. We have taken over from Ferguson's Marine Engineering, who unfortunately started the process in 2018 but went into liquidation. So we have taken on the design, which will be starting actually next week, and we will feed that back into the consortium partners. Next slide, please, Christina.
Oh, it's thinking about it. There we go.
So HySeas III consortium partners, from the top, St Andrews University in Scotland, CMAL, the company I work for, Orkney Islands Council, who are the operators of the ferry at Shappensea at the moment and the likely operators of any new vessel we'll design. We've got Kongsberg in Norway, who are doing the fuel, the drivetrain system. They are the system integrator. Interferry and Auxilia are doing the dissemination. We have Ballard fuel cells. We have DLR in Germany that are bringing together the information and part of the dissemination through to the EU. And McPhee in France, who are looking at the hydrogen installation on the shore side and the bunkering operation, which is a very important part. Next slide, please, Christina.
Apologize, there's a bit of a lag, so I'm clicking away, but it doesn't seem to listen, so please excuse my slow computer.
It's going well. The reason we chose Orkney is at present Orkney is the part of Scotland that has went most advanced with hydrogen fuel already. There's an awful lot of wind in Orkney. There's an awful lot of wind in Scotland. Two things we have, wind and water. We need the water for whisky, and we're using the wind now for green purposes. We have wind turbines throughout Scotland, but on Orkney, and we also have electrolyzers, which is taking the nighttime energy, if you like, and converting into hydrogen. The term free hydrogen, I always think, is a good one. Electrolyzers are not cheap, but the intention is to use the green hydrogen on this ferry, which will run from Kirkwall to Shappensea. Orkney ferries are already using hydrogen in there's a small 75 kilowatt fuel cell for shore power for some of their vessels at the moment in Kirkwall. And also as part of the HyDime project, they have a small generator on board the existing Shappensea ferry. And this is all good information finding to lessons learned and put together a good training process for the staff that will be running the hopefully soon to be completed Kirkwall to Shappensea hydrogen ferry. Next slide, please, Christina. And there's a small system overview of how we see the setup with the ferry and also the drivetrain system, showing fuel cells, batteries, the integration, and obviously fed from shore power as well. All brought together by Kongsberg of Norway. Next slide, please, Christina, and I believe it's on to yours.
Yes, thank you. So now that you all have a brief overview of the HySeas project, I wanted to give you a little bit of Ballard background and the actual fuel cells we're using in the land-based string test, as well as the FC Wave, which is the next generation of marine fuel cells. So the focus at Ballard is really decarbonization of North Sea shipping. So we have gotten in the Marine Design Center, excuse me. So this is just the global scale. The shipping industry is contributing a significant share of greenhouse gases. You can see 2.2% of the CO2, 15% of the nitrous oxide, and 13% the sulfur dioxide per year. So that's what we're looking to make a dent in. And as you can see, the zero emission requirements that are coming to the marine industry are really going to be a big factor in ship design going forward. So what we are looking for now, with the IMO is phasing out greenhouse gases down 50% by 2050. Norway is protecting their fjords, and they're going for a 2026 100% zero emission stand. And the Europe EMA is to cut CO2 also 50% by 2050. So at Ballard, we are building the next generation of hydrogen fuel cells for zero emission marine vessels. They'll give a longer range to ships, the fast and flexible refueling when the bunkering infrastructure has been in place, scalability and modularity. Right now our fuel cell for the marine industry, the FC Wave, will be running at 200 kilowatts. We'll be offering it in megawatt solutions, so you can add or subtract as many fuel cells as you need, and it is stable and reliable power. So Ballard in Europe is really the leading fuel cell company. So you can see here that I've got a picture of Norled. That's a picture of our building there on the top. Some of our workers getting it done, and our offices where you can see everybody's busily working. But we are invested in over 60 R&D projects. We have over 18 years experience. We've got a manufacturing capacity of 60 megawatts a year. And we are literally growing 80 plus employees. I think we're over 100 now. And we have a very good partner and customer base. So right now in the HySeas project, what we're doing is we're actually using one of our bus fuel cells in this land-based string test. So we've hooked up 6 HD100 FC velocities. So those are 100 kilowatt fuel cells that are working in tandem in this string test in order to prove the theories. And as you can see, they've been on the road for a while in buses and trucks. We've got over 50 million kilometers in service, and 3,000 trucks and buses are deployed by our hydrogen fuel cells. But our main focus right now in the Marine Design Center is what we like to call the FC Wave, and that is our marine special fuel cell, 200 kilowatts. It is right now we've built 2 prototypes. We are doing testing and we are getting class certification with the EUDP and Lloyd's Register right now. As you can see, they're scalable from 200 kilowatts, so we can really go. We're working on a 1.7 megawatt system at the moment. It just says 1 right here. They're powered by the FC Gen fuel stack, which offers a significantly lower life cycle cost. We're meeting all of the most stringent safety standards, especially with hydrogen and the volatility that can be found in that gas. We're doing all we can to make sure that the safety standards are met and even exceeded. The ease of integration, we're looking at a container solution as well as just the fuel cell. So it really would be a plug and play solution for ships. And our reliability is very, very top notch. We are using data from our buses and trucks, and we're able to say with some confidence that the reliability of our fuel cells is very high. So here's some product specifications for the FC Wave. I don't know if you can, it's pretty small, pardon that, but it is, I'm going to leave this up so you guys can look over it. There's no reason for me to sort of read it out to you, but it is, we're working on the H2 pressure right now is 3.5 to 5 bar, which I'm not sure if that means anything to anybody, but they're quite excited about that. And the life cycle is about 34,000 hours per, and that's at full tilt. So we've designed this for ease of integration. We've integrated into a clean line cabinet with easy access doors. It actually splits in the middle, which you can't see in this picture, but there's an upper cabinet and a lower cabinet. And then all of the connections you see there at the bottom, those can be installed under a false floor in order to fit into some ship engine rooms at the moment. You can make the connections below floor level, and it's flexible and modular, so it's minimizing the space required in a ship. And here's just a quick picture of our modular installation layout. So that would be 3 of our FC Waves just put together. We're also developing something called a master controller, which will then be able to unite all the controls of however many fuel cells that are necessary on the ship, and we'll be able to control them from one controller. John, I wanted to toss this back to you about the full-scale drivetrain test.
Thank you, Christina. So this is a drawing of what is actually happening in just outside Bergen just now with Kongsberg, the integrator. So we have load banks to give the ultimate loading that the vessel would require. Switchboards, multi-drives, load banks to demonstrate the bow thrust load, etc. And what they'll do is they'll run through all the various scenarios, ship speed, the manoeuvring alongside in port, and gradually work the way up to full loading. And it's been slightly delayed again due to COVID. It's very hard to get people around Scandinavia, as you know, just now, and around Europe. So it's been held back a little bit. Things are opening up now, and we hope to be running at full capacity by the summertime, the middle of the summertime. And the information that we'll gain from that will assist in the design of the vessel. Next slide, please, Christina. And a couple of pictures there of just how the setup is in Bergen. I believe there's 3 fuel cells in each container, and you can see in the picture on the right there the air cooling as well.
Correct.
And the ferry that we are starting the design with, we're working with partners Aqualis Braemar LOC down in Southampton, and the design, as I say, has only been initiated this week. We'll be looking for approximately 40-metre vessel. Drawing there showing one slightly larger, I would expect. It will be a double-ended ferry. It's a 1-in-8 concrete slipway that the vessels operate from, both from Kirkwall and Shappensea. But around Scotland, there are 38 1-in-8 concrete slipways. So we're looking at the benefit of a design here that can possibly be taken and operated in other routes, whether around Orkney, Shetland, or down the west coast of Scotland as well. Our company, Caledonia Maritime Asset, is also looking at the moment on all-electric vessels of a similar size and style. We're also looking in larger vessels at, as well as hydrogen, we're looking at ammonia and possibly methanol. The design that we're looking at here will probably be integrated through with we're looking at the electric Voith Schneider propeller, which has just come onto the market. It's given very good results for very lightweight and low energy. And all this combined with the fuel cells, with the batteries, should lead to a very green design. And we hope to have that design almost complete on the run up to COP26 in Glasgow this year. And that's when governments will be looking for projects to fund. And we hopefully will be taking the design and taking it to build in 2022. But no commitment yet. But hopefully, as I say, with the run up to COP26, there'll be some possibilities. Next slide, please, Christina.
Actually, I just wanted to really quickly interject. If you see at the very bottom there's a blue line coming out of the fuel cells. I'm not sure how that got cut off, but that is just the water. That is the output of the fuel cell, so that's going out.
Okay. And thank you very much for your time and being able to demonstrate this HySeas III project, which, as I say, is really just starting in earnest just now from COVID and other delays. And thank you very much, and thank you, Christina. And we'll be happy to answer
John.
Any questions.
Yeah, thank you for all your attention, and we're ready for your questions.
Yeah, thank you very much, John and Christina, for your presentation. And looking a little bit into hydrogen ferries, which of course may be an option for longer distance and also for ferry routes that involve heavy weather conditions here. Maybe from my side, one question. So you are in this testing phase of the drivetrain, I understood. Are there already first experiences with that you could share, or has it just started?
We've actually been delayed in our commissioning because of the inability of our techs to be in and on site in Agatnes outside of Bergen. We have achieved quite a bit through Zoom meetings and phone calls, etc. But we really need to get one of our guys up into Norway, and the quarantine requirements at the moment preclude that completely. So we're hoping that by the end of June we'll have a little bit of an easier time getting up there.
Okay.
It would be worth following that on was during the initial start and of the experiment, there was a hydrogen leak, and fortunately there was no issues, no problems. The safety protocols were in place. It had good publicity in Norwegian TV, and ultimately we lost 1 kilogram of hydrogen. But the benefits from us is that all the safety protocols worked correctly, and we can take that into the vessel design as well.
Okay. Also coming back to questions that we maybe had before, but under different conditions maybe. The question is also, John, you mentioned that you have you look into hydrogen ferry, but also into a battery electric ferry of a similar size. So from your point of view, then as the ship owner, where do you see kind of in Scotland, Shetlands, West Coast, where do you see there kind of the potential application cases, and where could a battery electric ferry be more suitable, and where could hydrogen be the first choice for you?
A very good question, and one of the issues we do have around Scotland is the power availability. We do not have, in some of the remote island areas, the power to be able to charge electric ferries. We have limited power, so in those instances it may well be the hydrogen would be the easiest option there. In other areas, in more busy areas such as down in the southwest of Scotland, plenty of electricity, and we're probably looking at battery ferries for there. But in the more remote areas, hydrogen, and on the larger ferries, maybe moving on to ammonia and methanol in years to come.
Thank you for this information. No further questions here to this topic. So yeah, then I would like to thank Christina and John for introducing us to the status of the HySeas III project, which is a little bit delayed, but I think this destiny is shared also with the other hydrogen project that is going on. So this is the Hydra that is built in Norway, also for the operator Norled. And here we learn from Anders Setternes that also this is a bit delayed, so it's expected the ferry itself to come into operation this year, and but the hydrogen propulsion system will be enabled only next year. So hydrogen, I would say this stays a topic for the future, and I think it will be worth to go into this subject again a little bit later. In 1 or 2 times when there are also first operating experiences, and I look forward to this. So thank you, John and Christina, and so then just I would like in the end just to summarize the meeting a little bit, and also to give you some announcements from the side of the ELMA project. So first of all, I should send you again regards from Mario Heinrich, who actually wanted to say a few words here also in the end, but the connection is still too unstable, and I would like to forward his thank you to all the speakers and also to all the participants for their contributions from Mario Heinrich. So I think what we have seen here is that, electric ferries and pack ship, this is a segment that is in rapid development. I think hydrogen, this is at least my personal conclusion for this. This is something that is under development, that is close to become also applied. So already next year we will have first examples, and that will kind of also extend the range of possible applications for zero emission propulsion systems in maritime operation, in maritime transportation. And on the other hand, I think we had an extensive look to the battery electric ferries and pack ships, where I would say the conclusion could be where the technology, when it comes to the ferries themselves and also and the propulsion systems, is already very very advanced. And what we see now is that these propulsions are also now used not only in domestic car ferries, which were the first use cases, but that there are prospects also to go into other vessel types. This can be larger ferries like the color hybrids. So into RoPax, this can be fast ferries, but this can also be other types of ships. One of the examples we heard was, for example, short sea bulk shipping and also fishery vessels. So I think there is a lot of development potential with this, and I think this is also something that when it comes to the onboard package, there is already mature technology in place, but it was also addressed also in the beginning by Anders that when it comes to the connection to the grid and the on-share connections, there is still a bit of innovation and development potential, and this will be something for the future. So this was our look to Norway 3 years after our first visit there. And I would like to announce in the very end here that this was the last of our series of 3 seminars in the ELMA online in the ELMA project. And it will be possible if you could not join all the time today, or also the other events here. You see the topics again, or if you want to share this also and recommend this to others, then we will make our online seminars also available real life on our website. This should be ready end of this week, beginning of next week. So we have registered the recordings and also the slides from the presentations there, so that you can visit again and also dig a little bit deeper as if you like. So this is an offer that I would like to announce. And then in the very end, so 15 minutes extra, we have you. I would like to thank, first of all, my colleagues, Igor, Björn, and Kevin, who made all the work in the background for these seminars. And then I would also like to thank you, the speakers, once again, for their interesting contributions and presentations, and also you as the audience for your attention and also for your contributions to an interesting discussion. So thank you very much for joining us today, and hope to see you again in the future, maybe in a similar seminar again. Thank you very much.